Understanding electrochemistry and interpreting electrochemical cells. 1. Introduction to electrochemistry. Definition. Electrochemistry is a branch of chemistry that deals with the study of the interconversion of electrical and chemical energy. It involves the study of redox reactions, batteries, electrolysis, and electrochemical cells. 2. Basics of redox reactions. Redox definitions. Understand oxidation, loss of electrons, and reduction, gain of electrons, reactions. Redox equations. Write balanced redox equations for chemical reactions. 3. Components of an electrochemical cell. Anode. The electrode where oxidation occurs. Cathode. The electrode where reduction occurs. Electrolyte. A solution that allows the flow of ions, completing the circuit. 4. Notation for electrochemical cells. Standard cell notation. Represent electrochemical cells using the standard cell notation, which includes the anode, cathode, and phases involved. 5. Cell potentials and standard electrode potentials. Cell potential, E cell. The voltage difference between the two half cells in an electrochemical cell. Standard electrode potentials, E degree. Standard potentials for reduction half reactions measured against the standard hydrogen electrode, She. 6. Nernst equation. Nernst equation. For non-standard conditions, the Nernst equation relates the cell potential to concentration and temperature. Calculating cell potentials. Summing half reactions. Break the overall reaction into half reactions. Standard cell potentials. Use standard cell potentials to calculate the overall standard cell potential. Degree. Cell. E degree. Cell. Closing parenthesis. Nernst equation. Apply the Nernst equation for non-standard conditions. 8. Cell diagrams. Cell diagram notation. Represent electrochemical cells using cell diagrams that illustrate the components and their arrangement. Salt bridge. Include a salt bridge to maintain charge neutrality. 9. Faraday's laws of electrolysis. Faraday's first law. The amount of substance deposited or liberated at an electrode is directly proportional to the quantity of electricity passed through the electrolyte. Faraday's second law. The amounts of different substances deposited or liberated by the same quantity of electricity are proportional to their respective equivalent weights. 10. Applications of electrochemical cells. Batteries. Understand how batteries convert chemical energy to electrical energy. Fuel cells. Explore the use of electrochemical cells in fuel cells for clean energy production. Corrosion. Study the electrochemical processes involved in corrosion and corrosion prevention. 11. Corrosion and cathodic protection. Corrosion reactions. Understand the oxidation of metals in the presence of corrosive agents. Cathodic protection. Implement methods such as sacrificial anodes or impressed current systems to protect metals from corrosion. 12. Electrolytic cells. Electrolysis reactions. Study reactions that are driven by an external electrical source. Products of electrolysis. Understand the products formed during electrolysis. 13. Redox titration. Redox indicators. Use redox indicators to determine the endpoint in redox titrations. Equivalence point. Identify the equivalence point where the moles of electrons transferred are equal. Understanding electrochemistry and interpreting electrochemical cells involves a combination of theoretical knowledge, experimental techniques, and practical applications. By exploring the principles and applications of electrochemistry, individuals can gain insights into the fascinating world of redox reactions and energy conversion.